it goes. I stopped here last time. Okay. So I was here. We popped. We plugged in the -3. Okay. And now what? We have -27m and those numbers right to the right. Just that. 27 minus 81. So have a negative number on the right. And so the number is what? 50 something? 54? I think it's 54, man. Yeah. -54, and m is just going to be a positive number thanks to the division, and it's going to be 2. So m is 2. Now what? So basically the condition said that we must find m, which we did. And now we have to find the basically what's left of this division to this polynomial x to the second power plus 3. Alright, so that's that. And how is that possible? Well, if we plug in the m, we should be able to have everything correct to just divide it by x to the second power plus 3, right? This is what I should do. This is what we should do right here. Okay, so writing it down. The whole polynomial and divide it like that. Okay, so this will take a bit long, but it's for the sake of practice. So x to the fourth power divided by x to the second power, that is x to the second power, and that's that in the results box, and then multiply that with what is above. So we will have x to the fourth power plus 3x to the second power, okay? And like I said before, the 3x to the second power must be placed below the 2x to the second power, so we have the equal terms. And then the x to the third power, just place 0x to the third power. And that's how we work. I'm 100% positive that is the best way to solve this. So this is how it is being shown here. So basically it's shown if you don't have like this continuation next to fourth and next to third, you just have to add 0x and stuff. Okay, so we got this x to the fourth. Now we pop that in, plus 3x to the second power, and there we have plus 0x. And now we just do the division. I mean 0x to the third power to have same stuff. This is why we're doing it. So in the first one, nothing. In the second one, 3x to the third power. And in the last one, x to the second power. Right? No, it's gonna be minus x to the second power. Okay, so we got that. Now we get everything down. And now 3x to the third power divided by x to the second power is 3. Hold up, it's not actually 3, it's 3x, right? Yeah. And now 3x times that. 3x times x to the second power, that's 3x to the third power, which is very good, as we can just negative that and it's going to be nothing. And then 3x times 3, that's 9x. Place that under 7x, and we're going to do the same thing with x to the second power. Just place plus 0x to the second power. So place that. Now plus 9x below the plus 7x. And right there plus 0x to the second power. And then nothing right there. Right there we have minus x to the second power. Nothing changes. and right there minus 2x plus 3. Now obviously we work with minus x to the second power divided by x to the second power, which will be minus 1. Place that, and then we get minus x to the second power right there, and minus 3 right there. Okay, so the rest should be minus 2x, because that's that. Actually should be different. It's gonna be right there 3 minus minus 3, which is gonna be 6, so it's gonna be minus 2x plus 6, and that's we stop here because we cannot divide minus 2x to the x to the second power. So doing the division, we have received plus 6 right there, and we're done. So the result, the rest, and pretty much the m what we got there. Okay, so this video is done. We're gonna move on to another video. Looks like I've started watching this one, but I'm not sure how much I watched, so let me see if I can get something out of this. We do have another video with another teacher, so let's skip to the important part. This in equation I don't really remember. I don't really remember this stuff, so perhaps I didn't do this stuff, so yeah, we're gonna work with this. Like, come on, it's just in equations, like come on, man, this one's a bit tough, like. Anyways, I guess we can work it through, mostly. I don't know how to place this condition so well. Should I actually watch this? Perhaps I should watch something else. Well, there are some exercises without conditions. I don't know. I guess let's watch it a bit. So start off by saying the solution or something. The r is not 0. I guess based on the sign. Like I said, I don't really know these conditions. Okay, so we got that. X right there. X to the second power is like that 4. And why is that? Because if you multiply diagonally, you're gonna get exactly this. Okay, that makes sense. So after this, let's see what we have. 2 right there. That makes sense. Just square root of other parts, and then minus x is also the same thing, because at the second power it can also do the same stuff. Either it's x or minus x. So we've got that. 2 like that, and right here we got the negative sign and this sign, so we just flipped and put a minus 2 right there. And now we're just gonna place this on an X, color circle, both. Okay, so from 2 it's going to plus infinite, and minus 2 just the opposite. So these are our intervals. So it cannot be 0, it's not even there, so response is from minus infinite till 2, minus 2, with a parenthesis like not the ordinary one, and then reunion with from 2 till plus infinite. That's bad, man. I mean, this one's not hard at all, but you know, just have to know that deviate not 0 and stuff, which I guess not that many know. Okay, so this one should be even easier, for me at least, because you don't have to know the DVA is not placed here when I skimmed through the video. So 0.25. Here what you have to do when you see exponents like that, you need to get the same base. So when you have 0 point something, you just write it down as a fraction, which is going to be 25 by 1 divided by 100. So simplified by 25, which is going to be 1 divided by 4, and that is the power of x plus 3, smaller or equal to, okay, so we have 8 right there. We can put that to 2 power 3 times 2 a power of x, and we work from there. The 1 divided by 4, we can put a power 2 power minus 2, so I got the same base, multiply the stuff. I think I did similar in equation, but anyways, just rehearse a bit. Maybe I didn't do something like exactly like this, so skipping a bit. Let's see how it's done here. 1 divided by 4, yeah, that is absolutely correct. So this is how the simplification is being done. And now we can move from here like this. Okay, we got that. Minus 2 right there. X like that to the power. Alright, so we got that. Right there, you're just gonna multiply minus 2 with x and then plus 3. So it's gonna go like that, and once you got like those same powers, if it's multiplied, it's gonna do a plus, so it's gonna be 2 of the power of 3 plus x right there. And now we just work with the powers. We got the same base, so it's gonna be minus 2x minus 6 equal with 3 plus x, and we solve for x, and that's it. Place it on a graph to understand the interval as it is on an equation, not equation. So we've got this. Let's take the exponents out. Now DVA, we're actually going to do DVA. So far we've got this. Move the x terms to the left, the rest of them to the right. So we have 9 to the right, and then minus 3x right there, which leads us to x smaller or equal to minus 3. Okay, so the sign has been changed. Why? Well, I guess that makes sense. It's kind of tricky. Like, when you move a negative number towards the right, you actually need to change the sign. So it's now actually bigger and equal to minus 3. And now it just plays that on the graph. And as it is with equal, we just pop the parentheses like that, and we move along. Okay, now we got this equation. At least not an equation. So 4x plus 12. Let me see something real quick. I think it's DVA like bigger or equal to 0. So I was here, of course, and like I said, the deviation should be 4x plus 12 bigger or equal to 0, as far as I know. And now 12 minus 12 right there, and it's going to be x bigger or equal to what? 2 minus 3, right? Okay, so got that. Place it on the graph. And actually we don't need to place it on a graph. Minus 3 till plus infinite with parentheses like that because it's bigger or equal. Now we actually solve this. And how to actually solve this, it's quite simple. You just have to get everything to the second power, so when you get the left part to the second power, the square root will be removed, and the right part is going to be x to the second power. Move the right part to the left, equal to 0. Solve the quadratic, place the values on the interval, and just see which ones are valid with the DVA. That's it. So that's and x to the second power. To the left it goes, and we have exactly this. Looks like she wanted the x to the second power to be positive, so she moved everything to the right instead. And we now solve using the delta. 16 plus 48 right there, and that is 64, right? And which is 8, which is the square root. And now x1 minus b4 minus 8 divided by 2. How much is that? Minus 2. And now the next thing is going to be 6 right there. And now we have that. Now we place it on the interval right there. Okay, so perhaps we don't even need to place it on the interval. So if we think about it, minus 2 is more is contained within the interval, and 6 is also contained. So we have visible values, right? Valid. X minus 2. What, only that? No way. If we place it in there, we will have square root of 4 square root of 4, right? And that is going to be minus 2, which is not right. I think it's not right. So you have to verify like this, like what? Okay, now 6 right here, that's no problem. You can get 24 plus 12, 36, 6 is valid. So the solution is 6 right here. This one was a bit tricky like there to the end a bit. Okay, now we got this like longer in equation, but I think it should not be like that hard thanks to the exponents being worked with right here. Okay, so in terms of a DVA, I think we do the same thing, like what's under the square root, bigger or equal to 0, and then the other stuff. 3 times that, 9. Well, the 9 we can write down as 3 at the power of 2, and it's gonna be like that. We have 3 right there, another 3 multiplied right there, a 4 right there, plus 1. Well, you don't really know how this one's done. I can guess, but I'm just gonna see how it's done. Okay, so we've got this value right here. dV is going to be what? What is it, the parenthesis or just the square root? So square root right there. We just switched the sign and we have received this. X has to be smaller or equal to 1, so it's going to be from minus infinite till 1 with a parenthesis like that. Non-regular parenthesis. Square 1. Okay, now what? Some dVA values explained, I guess, right there. So basically now we took the expression out and we just completely ignored the square root. I guess I can get it. I don't think it's going to be necessary for me to understand better why that happened. So hold up a bit. Okay, so we have that same inequality sign. Yes, I have proposed that it's going to be the power of 2x right there. So now they have the same thing. Okay, so now what I see here, perhaps we can solve this by annotating 3 to the power of x as t. So when we swap that in, we'll get a quadratic equation which we can solve, and thus we'll get our values. Yeah, so this is exactly what will happen. 3xt has to be bigger than 0. Why? I don't know, but anyways. Let's see. So second power, that's exactly quadratic. And we have a 16 right there, minus 4 times 3, which is 12. So we will have 4, square root of that is 2. 4 minus 2 divided by 6. That is 2 divided by 6, that's 1 divided by 3. And the t2 is just going to be 1. Okay, now we have both t values. And we have to equalize these values with 3 to the power of x to understand what x is. And we're just going to swap that in and solve it. But we actually need to solve it, we just need the x, right? So that is that. So what power should I place there so that I get 1 divided by 3? Minus 1, because that will flip it like that. That's pretty easy. And then 3 of power of x equal of 1, what power should I place? 0. In number of power 0, there's just 1. So I don't know why she just placed the t values right there. Shouldn't we swap it with the x values? Anyways, they're placed right there. Now what? Goes like this down and then hold up. Goes down and up. Parabola or whatever it's called. So it's basically between these values. What was our dVA? I don't really remember. And it goes like this, perhaps. So 1 divided by 3, that's just like 0.3. And if I take 1 divided by 2, which is 0.5, and place it in there, like let me see, let me get to, for example, 0, right? 0 right there, 0 right there, so positive. Okay, so this is how we get the values, and we need negative or equal to 0 values, so we get those values, parentheses like that. and now we will get the x, so x minus 1, x is 0, and x from minus 1 till 0, right? Okay, so the dva has to be, x has to be smaller or equal to 1, and we have this fulfilled, right? Another graph, what? Minus 1 and 0, that's the x values. Now we're gonna place the dva values from minus infinite till 1 right there. Okay, we got that, and basically the response is from minus infinite till 1 till 0. Okay, so this is done. Essentially what we got of x values right here is the same fucking interval. Okay, so we got this equation. I mean, this one should be a bit harder than usual. LOG and stuff. I think in the LOG, dva, you just have to take what is in the parentheses and put it bigger than 0, right? This is what should put it like, I think. So solve the two dvas because we have two parentheses, and after that, well, what do we do? LOG2 like that. I don't think in this one we should also annotate with t. Is that really what we should do here? It's going to be LOG2 with base of 2 of t. No, look, here's we have the same base, so we should multiply them, right? LOG2 is going to be x minus 1 multiplied by x minus 2, like that, in parentheses, equal with 1, perhaps like this. And again, I'm not sure about the dva values. Okay, so dva right here, LOG2, the base right there, LOG2 again, I know. Okay, so I was right with bloody dva, so that's good to know. Now first thing will be x bigger than 1, and second one x bigger than 2, right? Okay, now on the graph, place 1 and 2. 1 and 2, and basically the values overwrite from 2 till plus infinite normal parentheses. That is our dva right here. Now, let's see the property. Okay, so yeah, I was right. Okay. And we work with the 1 like in the usual way we do. LOG22 is 1 based on the property. If it's the same base and then the factor, it's just 1. So now we have the same basis, so we can just actually write it down without the LOG and the 2 base, and we're gonna find values. So we've got that. Now we just multiply term by term. We'll have x to the second power minus 2x minus x plus 2. So just quadratic again, once again. All of the time is quadratic and Pythagorean theorem. Okay, so we have minus 3x, and when that 2 is moved to the left, is just gonna leave us with nothing. And we got that. Now we just place the x up front. So this will leave us with x, then x minus 3. And x is going to be 0, and x minus 3 is going to be 0. So x is going to be 3 once again, so we have like a system and stuff. So actually she wants to solve a delta. I guess this is the method. You just say that the last c is 0, so you're going to have 9 minus 4ac. So why is it 9? Why is the delta 9? Basically 9, yeah. Minus 4 times a, which is 1, times c. Okay, so c is 0, so okay, so that's 9, okay. So square root of that is 3. First value we have 0. Second value should be 3, right? Okay, so we got that. That's first method. Now the second method is like how I explained. So that's that. You can take your pick. I think they have the same grade of difficulty. And now we have its values. We have dVA. And what do? Well, we just simply write down the dVA on the graph and the x values and see where they go. Actually, she just went over and understood what values fit there. So 0 obviously doesn't fit there because it's not bigger than 2. And 3 fits there because it's bigger than 2. So we have 3. Solution right here. Okay, now we have some properties explained. Not gonna get into that. I mean, yeah, you can understand about these properties, but I just prefer to watch examples and so on. Okay, so I've got this. Now, I think there's a dVA parameter when the fraction is being divided by something, so the x minus 1 should be placed under dVA. I think it's gonna be bigger than 0. So we got that, and in order to solve this, we will just I mean, we can multiply diagonally, right? Or there should be other methods. Let's see about it. Main thing is to know like dVA anyway. Okay, so I fucked up, obviously. So yeah, perhaps I encountered this, but I forgot. X minus 1 must not be equal to 0, which is kind of intuitive maybe, because you cannot divide by 0. I think you can divide 0 by something, but not by 0. Anyways, fuck this stuff. We got that. X not equal to 1. And basically if we get like value of x1, that's not going to be valid, so we're going to work with that. So all real values except 1, that's just how it has been mathematically written out. Okay, so now we go over this diagonally like I proposed. We're gonna have x to the second power minus x, and when we move that 2 to the right, it's gonna be minus 2 right there, and all of that bigger or equal to 0, so quadratic once again, hello. And we get the values and compare to dVA. I mean, this one's pretty straightforward, not gonna lie. I have no issue with this one. Okay, now get values. Delta right here. B to the second power. It's gonna be just 1. Formula for you. we just used it 10,000 times. Minus 4. So it's gonna be 9 because it's plus 8. And that's 3 when you extract it. And now minus 1. Okay, 1 minus 3 divided by 2. So that is minus 1, which is not equal to 1. So it is admissible. And now the next one, it is 1. Actually 2, so it's also admissible. And basically we have to place this on the graph. Okay, so maybe not. Basically plus infinite right there, minus infinite. We place minus 1 and then 2 over there to the more to the right. And it has to be bigger or equal to 0, so place 0 somewhere. So I think the values should be from 2 till plus infinite, right, with not regular parentheses. Minus 1, 2, place with 0. Okay, so the graph has been written out. If I will place value 1 in there, I'll have 1 minus 1, which is 0, minus 2, so it's negative, so positive, positive. And yeah, I think it's solved differently here. It's kind of hard to not fuck up and understand when you have to just scratch it or when you have to do this lines. So we need positive or equal to 0 values, so we're just going to be from minus infinite till minus 1, reunion with 2 and plus infinite. That should be the result. And that is it. Of course that's the result. Okay, so moving on from here. Some exponential stuff in equation. Like this, man. Here, I think dV is not necessary, as far as I know. 49, that's just 7 to the second power. And to make it the same base as 1 divided by 7, I'm gonna, what can I do? 7 to the second power, that is 49. And, oh, actually, yeah. First, 1 divided by 7, you're just going to write it down as 7 to the power of minus 1, and so you have the same base, and now you can use the x values, and you're done. So this one's not hard, I think. 7 minus 1 right there, power, correct. And place the inequality sign correctly. So that is how it's done with the green text right there. And now x plus 3 right there. So we have that. Work with the x stuff. So basically what is in the power. So minus x is going to be smaller or equal to 2x plus 6. So come on. Alright, we have this. Move x values to the left, minus 3x. Right there, smaller or equal to 6. Boom. And now we move a negative value over to the right. We have to change the sign. And it's going to be x bigger or equal to minus 2. Okay, we have that. And there's no DVA and stuff, so we're absolutely fine to just write it down as essentially solution from minus 2 till plus infinite, right? With usual parentheses. I mean non-usual parentheses, so this one is clocked. Okay, now we have some square root action. What's under the square root? Yeah, perhaps bigger or equal than 0 dVA stuff. And what else? I mean, that should be it, right? You have a usual square root of minus x, and that, how do we solve it? Okay, so yeah, I mean, what are you even thinking about? Just everything to the second power, everything. And we're just gonna solve it, like, it's not even a problem. dVA and that and that. So just switch the sign, x smaller or equal to 0 on first thing. And on the second one, it's going to be minus 5x smaller or equal, actually bigger or equal to minus 12. And then once you do the division, it's going to switch the sign once again. Okay, good girl, sign has been changed. Now that's right there, 5. Where'd the x go? Forgot the x. Anyway, it's gonna be 2 negative division, so 12 divided by 5 right there. X is gonna be smaller or equal to 12 divided by 5. Okay, we got that. Placing this on the, like, this value is like, okay, so has to be 12 divided by 5. That is essentially bigger than 0, right? That is about 2.4, or exactly that. So it's going to be from minus infinite till 2.4 with a funny parenthesis. Okay, so I'm going to take a quick break and be back.